RMS Software Debugging Platform. Quick Start Guide. The RMS is an intuitive and robust tool for electric actuator debugging. This tutorial showcases its core features: connection setup, command editing, charts collection, perms adjustment, I/O mapping, and I/O monitoring. First, software connection. Launch the software from the installation package and double-click to access the interface. Switch the language by clicking here. Toggle between night and day modes with a single button. Click on Connections to proceed to the connection interface, which will prompt you to confirm the controller interface connection. Select the controller model, and the interface definitions will be displayed for your confirmation. If correct, or if using the ITG series actuators, you can skip this step. Typically, electric actuator debugging uses Modbus RTU for connection. The default baud rate is 115200, and station ID is 1. Upon successful connection, a complete menu navigation bar will appear on the left. This bar can be shown or hidden, and clicking it will display multiple functional panels on the right. You can freely adjust, expand, or reduce these panels according to your needs. Second, Commands Editor. Commands Editor interface is the most frequently used for controlling the actuator, setting commands, and displaying motion status. Common command buttons are available in the command area for quick access. Backward / forward are used for the actuator's micro-adjustment in jog mode. Stop halts the actuator's motion as commanded. Initialize is a mandatory action after the actuator's first power-up or after a power cycle. Click Initialize and wait for the completion signal to proceed with other operations. Wait until the initialization completion signal changes to -1 before performing other actions. Reset error clears error when the actuator is alarmed. Check the error information by clicking on the Operate status in the left navigation bar. Before clearing the error, review the error information to assist technical engineers in troubleshooting. Reset force is specific to the soft force precision force control actuators for zeroing the force sensor. Turn on servo, turn off servo, turns the actuator's servo on or off. The servo can also be controlled through the servo switch in the left navigation bar. After creating or modifying a command, click Save to Controller to make it effective. You can also load it from controller to verify if the current command is saved. Additionally, there are options to export to file and import from file for convenient saving and importing of parameter files externally. Now, let's explore the command editor. Command number is the system's default sequence number for triggering the motion of the current command. Next command is a user-defined sequence for executing a series of commands in a specific order. It determines which command sequence to execute automatically after the current one completes. For instance, if you want the motion to start with command 0 and then proceed to command 1, you would enter 1 in the Next Step field. The default is -1, indicating the end of the sequence after this command. Common types of motion commands include absolute motion, relative motion, push, and precision push. Absolute motion sets an absolute position value. Note that this command should not be used directly for gripping or pushing actions. Relative motion is similar to absolute motion, but the position value is relative, meaning it adds or subtracts from the current position. Push motion uses open-loop force control to grip or push workpieces. It's an auto-adaptive command that can grip or push workpieces of any size within the travel range, based on the set force percentage. Precision push motion is similar to push motion but is specific to soft for precision force control actuators, used for closed-loop precision pushing or gripping. The set force value is in newtons, allowing for very precise control of small or constant forces. For example, a common setting for an electric claw gripping command is absolute motion plus push. First, select absolute motion and set parameters like speed and acceleration, then select push, motion and set parameters for force, speed, and distance. After that, set the jump order in the next command. Once the settings are complete, click Save to Controller to activate the command. Remember, any changes to the command parameters require saving to the controller to take effect. Through the status bar displaying position, velocity, output force, and received force values, we can visually monitor the real-time changes in the actuator's force, position, and speed status. Charts collection. During the actuator's debugging process, we often need more intuitive data for analysis. Click on Charts Collection in the navigation bar to access the Data Collect setting and Data Collect command bar. Before performing offline acquisition, we need to have the motion commands ready in the Commands Editor from earlier. For example, here we set Command 1 as the action for the acquisition object. If you need to adjust the command parameters, you can return to the commands editor to make changes at any time. Check the variables you need to acquire. Typically, we commonly use the current position and current force as the variables for acquisition. The default number of counts per channel is 500, but it can also be set to 1000. The controller's memory will automatically allocate the number of acquisitions based on the number of selected variables. The default frequency is 1000 Hz, but you can choose a higher frequency or customize it. The higher the frequency you select, the shorter the acquisition duration will be. Data collect commands can be performed for current collect, persistence collect, or for a specific command. Here we choose the execute command number as 1, which corresponds to the sequence number 1 command in the command editor. Click Start Execute Command and Collect, and after the acquisition is completed, the left curve chart will display the motion data defined in the commands editor for command 1. By moving the mouse, we can view the changes and values of the current position and current force during the execution of command 1. There is a selection icon in the upper right corner. After clicking, you can select a period of time in the curve for more specific data analysis. Click another icon to cancel the selection. Fourth, Params Editor. Params Editor refers to the modification of internal parameters of the controller. Here, we have categorized various parameters, and you can directly click on the corresponding options to adjust other parameters. A special reminder is that before adjusting the parameters, you must first export params to file the current parameter values to facilitate parameter recovery in case of incorrect modifications. Now, I will demonstrate how to configure I/O functions in the Params Editor. Click on I/O in the parameter classification on the left, and configure the desired functions for the external I/O input mapping and external I/O output mapping. Click Save Params to Controller, and the I/O configuration is complete. In the RMS debugging software, there is another way to define I/O. Click on the I/O map in the left navigation bar. By connecting the input and output params on the left and right sides with the I/O interface in the middle, you can associate the I/O ports with the required functions. To delete a mapping, simply select the connection and press the delete button to remove it. This method makes I/O definition simpler and more convenient. Fifth, I/O monitor. The I/O monitor in the left navigation bar can determine the execution status of the command. A blue switch turned on indicates that the command signal is in place and the action has been completed. After completing the debugging, please click Save Command to Controller, then click Disconnect, and the actuator can proceed to the next step of control with the PLC, industrial computer, motion control card, touchscreen, and other higher-level machines.